Alright. Here's the hope. Hopefully you're getting a feel for this. I will be sending out the answer key to the mole conversion practice sheet that I gave you guys. That'll be getting sent out tomorrow. So be looking for that. Besides that, if you can solve these two, then you're doing really good. Here's the thing. I face this every time I deal with this. This class is not just math, it's conceptual. Everything I've taught you is fair game. You need to know everything. It's great you can do a mole conversion. You're absolutely going to do a mole conversion. You might do a couple. But you have to be able to do multiple things. Then you have to know multiple things. Remember how this whole thing started. We talked about the international system of units. I gave you 7 quantities of measurement and 7 of those units. You got to know those. You got to know why the international system of units was created. You have to know
by the second surface.
You have to know why international system of units exists. Then you also have to know different little things like, remember we talked about the parts of an atom. Talked about 3 subatomic particles. What happens if you change one of them? You have to know that. Talk about radioactive isotopes. What are radioactive isotopes? What do they do? What's isotopes? These are just like a few things I'm throwing off. You have to know. So, congratulations if you can do a mole conversion. This is more than just a mole conversion. That's why I typically give you a week heads up to let you know when a quiz is coming. So, let's work this thing. So I decided to beef it up just a little bit extra from yesterday. So yesterday I gave you a new molecule. As I have done today, I tell you, you have 751.6 cubic centimeters sample of a new molecule of Y5T8. The only information you have been given that the element Y has 3 isotopes, with Y-74 having a 37.5% abundance, Y-76 having a 21.5% abundance, and Y-80 having a 41% abundance. Element T has 2 isotopes as well, with T-102 having 41.3% abundance and T-105 having 58.7% abundance. With the sample in a room of standard temperature and pressure, calculate the mass of this sample and calculate the number of molecules. So in this case, I'm asking you to calculate the mass and calculate the number of molecules. There's 2 good answers here. You should end up with 2, not just 1. So, throw this out there too. If you are still struggling, you have today, you have lunch, you can come see me. Feel free to do that. You also have, just like if you got like a class that's not like totally intense that you can sneak away from for a little bit, let me know and I'll tell you if you can come in here. Yeah, you got in the morning. By like in the morning, I mean like at 7:05. You can come in, I'll help you tomorrow at lunch, kind of stuff. And then Friday you got the quiz. So if you are still struggling, I've literally put so much time into this, I've put more time than I should. I've just done it because I know what happens later on. So please, for the love of God, get it down. So the fact that we are being asked to calculate the mass means that I will need the molecular mass of this compound. And I know for a fact if I'm going to calculate the molecular mass of the compound, I have to know the average atomic mass of element Y and of element T. But those are not elements off the periodic table. So there's no use for me to pull out the periodic table to look at the average atomic mass on this molecule. Can you do it on the other ones? Absolutely, you should. But in this case, we have to calculate it, which is putting your wonderful skills of calculating the average atomic mass to use. So here's what we're going to look at. calculate this average atomic mass. So look at that. So for element Y. Hopefully you get to where you can see where I'm jumping at, I hope. So Y is 74. So I have 74 grams per mole times 0.375 plus 76 grams per mole times 0.215 plus 80 grams per mole times 0.41. So that'll be for element Y. I can also do element T. The element T, I have 102 grams per mole times 0.413 plus 105 grams per mole times 0.587. Throw these both in calculator. At 76.89 grams per mole. That one. I got 103. 0.761 grams per mole. So those are the average atomic masses of element Y and of element T. If these two elements would have existed, I would have used the periodic table. Since they don't, I have to calculate that. Now, I need the molecular mass. So in order to get the molecular mass, I need to use those two numbers I just solved for. So molecular mass. So the molecular mass, I'll look at element Y, element T. These are the elements that are present. Element Y, if I look, it's Y5 T8. So there's 5 Y's and 8 T's, and I multiply that by their average atomic mass. We just solve for it. So 5 times 7. 384.45 grams per mole. I run my space. Man. 830.088 grams per mole. Add this two together. You get 1,214.538 grams per mole. So that's a good piece of information. You guys should have told me you couldn't have seen that. I would have slid it over. Talk to me. Don't be scared to talk to me. So now I have the molecular mass. So I have molecular mass. I can now solve to get to mass. I know Avogadro's number, so I can get into the molecules. Give you a second to get it wrote down. I don't want to leave you in the dust.
I'm just gonna take an educated guess here and say that at the very start you didn't have to convert the cubic meters yet.
You
Okay.
did. You have to. Very good.
No.
All right. Very good. So starting this problem off, I start you with 751.6 cubic centimeters. So let's make a plan. Gotta get a plan. I'm starting in volume. I go from volume to mole. Then from mole, I have to go two different places. I have to go mass, but I also have to go molecules. Okay? So when you look at volume, there is a key trick here. Can you use cubic centimeters?
No.
No. We can't use cubic centimeters. We have to take cubic centimeters into milliliters. But you can't use milliliters. This is why I like this trick. It's a trick and a trick. You have to convert it to liters. Then you can go from volume to mole. Okay? Hopefully you caught that. Hopefully you can do that. So it's 751.6 times 10. Oh, -3 liters. 5T8. I set it over to 1. Any questions where I got that number from? No questions? Very good. Hey, I'm still seeing a couple mistakes.
Hold on. Every time I type in for element T, I get 103.239. Did you type yours in wrong?
Did you type yours in wrong?
No, because I typed it in like 4 times. It's tripping me out and I don't know why.
So 102 times 0.413 plus 105 times 0.587. I couldn't type it. I get 103.761.
My calculator's just done. It's
So
okay.
you calculate.
No, it's alright.
Oh, no. We gotta see this calculator. Go ahead. Okay. Okay. You mix the fives and the
Yeah.
zeros.
I was freaking out, but I was like, something's not right.
It's all good. Thank you for asking, though. Okay,
Freaking out.
I'm still seeing problems here when people are setting problems up. You take the number you start with and you set it over 1. I can't stress that enough. Take the number you start with, set it over 1. There's no unit with the number 1. It also is not a conversion factor. Other people are trying to make it a conversion factor. It isn't. Now, I'm in liters. Here's the key point to this. In the problem, I tell you, in a room, standard, temperature and pressure means you can solve it. So let's set it up. All right, I'm trying to go first to mole. So I'm gonna do 1 mole, Y5T8, over 22.4 liters of Y5T8. Liters of Y5T8 cancel. In this case, typically I set all my conversion factors up all at once. I'm going to 2 different locations, so I will need this next number twice. So I'm gonna go ahead and do this one in the calculator.
0.0335.
So I get 0.03355 moles Y5T8. Okay, the reason I did that is I need to use that number twice. So I'll leave that number there, but I also will bring it down here. I'll set it over 1. I'll also take this number I just got, here, set that over 1. So it's like I'm just setting up a new problem. It's all done. So you can choose, you can go to mass on the top, mass on the bottom, molecules on top, molecules on the bottom, doesn't matter. You're starting with the same number. What matters is we set this up right. So up top, I'm gonna go mass. So this one is for mass. I set my conversion factor up. I'm going to mass, so that's grams of Y5T8 on the top. Liter mole, so 1 mole, Y5T8 on the bottom. There's a number that goes with this. What number?
Molecular mass number. No, that's for molecules, I'm sorry. Oh,
So 1,214.538. All it is this number came from right there. Moles cancel, that'll leave me with grams. So I'm gonna leave that as is right now. Let's go ahead and throw it in, why not? Store that number in my calculator. Hey, you guys are probably gonna retype this number in. Something I like to do is whenever I got numbers like that, all I've done is stored that number in my calculator so I can keep reusing it and I don't have to type in the big huge long number. If you ever want to do that, all you have to do, you see the on button right on top of it, the STL with the arrow, that's store. So that arrow says, it's the same answer, store. You click the alpha key, and then you just choose any letter you want. So in this case, I'm gonna go B. I've already stored it in A, but now I've stored that number as B. So if you see, I could go alpha B, and it'll give me the number. So when you see my calculator and you want to know where does A and B come from, I've just saved the number in the calculator. You don't have to do that. I'm just showing you because literally I don't want you freaking out when you see the video. You're like, what the world did he just do? Anyway, so in this case I got alpha A times 1,214.538. So I get 40.7521 grams of Y5T8. That's only one answer though.
I calculated later. Give me one, put it on there. I got close to something.
Okay? Did you type it in?
You got year on the whole number. You gotta have to look at it.
Huh?
that whole big old number, if you round up, you'll get the wrong answer. You gotta type in the whole number. It's annoying.
David, how far off are you?
Oh,
How far?
I just did the calculation you did, I'm just gonna stop there.
He's got 275, but the number's past that row. 0.75. He's got
The two
40
ones wrong?
Yeah.
That's just because you punched in the calculator. I saved the number. It doesn't matter. I won't count that against you.
He just put in like 0.3355 instead of the whole big round number.
Yeah, that's fine. All right, now let's go here. We gotta get the molecules, right? Set the conversion factor up. So Avogadro's number on top, so I'm going to molecules. One mole on the bottom. Moles cancel, leaves me with molecules, that's good. So I have, I'll set this up, alpha A, 6.022, third. That gives me 2.02. It's gonna be a 1 now. Didn't realize there's a 9.
It wouldn't be 1. Just 2.02.
Oh yeah, it's 6. Good save. That was the end of the 22nd. Molecules. Wi-Fi T8. Boom. Question?
No.
I got it down, I just somehow messed up on the first thing we did, which is,
Key concepts to get, okay, is 1, when you're dealing with volume, it has to be standard temperature and pressure. 2, you need to be able to go anywhere at all in the mole conversion. 3, know the units that have to be used because I'm going to trick you. You have to catch the metric conversions. Yes.
Can we use this metric conversion sheet on our quiz?
No. So you will have to be familiar with the prefixes and be able to do metric conversions. I know that seems mean. I cannot give you the mole map on your test, on the quiz. So heads up, if you like the mole map, be able to create it fast. What it's going to be like in here is when you come in on Friday. I will not meet you at the door with an entry slip. When you come in on Friday, you sit down. As soon as you sit down, I'm going to give you a periodic table. Why am I giving you a periodic table? Because there's a technique in taking the quiz called dumping. What dumping is when you have all this information in your head of numbers and stuff you have to have memorized, you dump it onto the page before you do anything. So if you're struggling to memorize Avogadro's number, if you have an acronym that helps you memorize metric conversions, if you have the mole map that you love to use, throw it on the back of your periodic table, because as soon as I give you the periodic table, do not feel like you have to ask me anything. I literally give you the periodic table. Flip that bad baby over and write as much as you want. Doesn't matter. At that point, I just gave it to you. So throw out there whatever you feel you need to throw out there. Other things, or you will have calculators. I will reset them. So do not try and store information in them because it's super easy. There's literally a button on the back I can just push and it resets it. Yes, David?
I'm guessing we don't get the prefix factor either.
That's what he asked. And I said no.
Let me set the, oh.